Now, students, if you have an event E1 and if you have another event E2, okay, whatever be the events, and if you do union operation between them, that is, now you have E1 union E2, and if that gives you the sample space, you have two events E1 E2, you're doing union operation between them, and if that gives you the sample space, if that is equal to what a sample space is, if the union operation gives you an answer which is equal to what the sample space is, then those events E1 E2 are called exhaustive events. These are not limited to two events. You could have many events E3, E4, E5, E6. It could be many events, but the the criteria is when you do union operation, how much ever events you have, if you do union operation between all those events, and if the answer is equal, exactly equal to the sample space, then those events are called exhaustive events. Now, what is the meaning of exhaustive? Exhaustive means complete, thorough, not leaving anything unchecked. These are all the meanings of exhaustive. We also use the word exhausted, exhausted and all when we are tired. Just basically means, oh, my complete strength is gone. We use the word exhausted. And exhaustive events means that everything is included. This gives you a more clearer meaning, not leaving anything unchecked. It's one meaning of exhaustive. Everything. So when you do the union operation in all the events that are given, you see that while doing union, you get the exact sample space. Do you see that? So because of that thing, these events E1, E2, E3, E4 are called exhaustive events. Okay. Now we will see an example of this. I have a set S, which is of course a sample space, and my experiment is, it's not exactly an experiment. I'm just checking which all subjects. Suppose you had an option to choose your subjects, and we being science students, we only have limited options. So suppose I just wrote this as at random. Okay, there are more subjects that you can choose. So, but suppose we have only these many options. These are the maximum possible, or these are the only possible outcomes. Okay, that the students choose. Just suppose that our sample space is containing the elements physics, chemistry, bio, English, maths, and Hindi. Okay. Now, suppose I'm saying there's an event 1 E1, which the student chooses science subjects. So the E1 shows the student choosing science subjects. There's another event E2 which shows the number of students choosing math subject, and there's another event E3 which shows the number of students choosing language. Okay, now if you look carefully, science is a subject. Science includes physics, chemistry, bio. Math is okay, another subject, so that is also taken. Language includes these two subjects, English and Hindi. Do you see that? So even though I didn't consider physics, chemistry, biology as different events, but by just combining them into science and language and maths, and if I just take a union of all these three events, I will get the sample space. Do you see that, students? E1 union E2 union E3. When I do that, I will get E1, which is this, E2, which is math, and E3, which is English and Hindi. Basically everything is covered, so I get the whole sample space. Okay, so this is just an example to show you what exhaustive events are. So exhaustive events are events when you combine them, that means when you do the union operation on them, you get the whole thing, the sample space. Okay, we will see again another example in a more better way. Okay, now this is what we saw in the beginning of the lecture, that is our probability ranges from values 0 to 1. It keeps ranging. 1 means absolutely going to happen, 0 means almost impossible, and the middle, it could, and it varies in the middle according to which is more probable and which is less probable. Now let us do a question. We have a dice and we are rolling a dice. The sample space is of course 1 2 3 4 5 6 because those are the only 6 numbers. Now my event is getting a natural number. Now students, what are the natural numbers what are the natural numbers that you can get while throwing a dice? Okay, anyways, you think about it, pause the video, do the question. Now my question is, what is the probability of E1? That is my question. Now if you solve this, you will understand that 1 is a natural number, 2 is of course the denominator will of course be 6. We know that the denominator will be 6 because the number of elements in sample space is 6. Now which all of them are natural numbers? We have 1, we have 2, we have 3, 4, 5, 6. All of them are natural numbers, right? So all 6 elements are there, so I write 6. 6 by 6 is 1. So you see that you get the answer 1. Now so probability of E1 is equal to 1, which is exactly the sample space itself. Do you see that? So so this example was given to just make you understand that the probability of the sample space itself is 1, because there is no more possibility than that. Sample space is the set which has the list, or which has the set of all the elements. You cannot go more than that, because 1 is the final value, like 100%. You don't so 100% is the maximum, right? And then in probability, when we scale it down, we get it as 1. So 1 is the last value, or the final value, or the greatest value that you can get in probability, which is of course the sample space itself. Okay, just keep that in mind. Now let us go to another question. Now my sample space is same, of course. The dice is same, so sample space is same, but my event, I have changed it. Now my event E1 is getting an odd number. I'm sorry, it should, as per the English rules, it should be getting an odd number. Okay, anyways, good that I'm not teaching you English. Okay, so E1 is getting an odd number. What is P of E1? Probability of getting E1. And we can see that there are the denominators, of course 6. We know denominator is 6 because number of elements in sample space is 6. What is the numerator? 1 is an odd number, 3 is an odd number, 5 is an odd number. So 3 elements. 3 by 6, which is 1 by 2, which is 0.5. Okay, you can express it in fraction. You can put it in fractions, no problem. I wanted to put it in decimals because I just want to make it very easy. Okay, now I have another set, event E2, which is getting an even number. So what is the probability of E2? In the same way, you can find probability of E2, which is even numbers are 2, 4, 6, 3 elements divided by 6, which is again 1 by 2, which is 0.5. Now this is where I want to look carefully. You have 2 events now. Probability of getting event 1 was 0.5. Probability of getting event 2 was 0.5. And we know that these two are exclusive events. Why? Because the set is different. In the first case, the set was 1, 3, 5. In the second case, the set was 2, 4, 6. Completely different. Do you see that? Those two events have nothing in common. So when we add them up, we get that P of E1 plus P of E2. When we add them, we get 1. 0.5 plus 0.1. And what is 1? This is the probability of the sample space itself, right? So suppose you have, and this is what we saw in the what we saw previously, where in the case of exclusive events, mutually exclusive events, just adding the events gives you the union, and in this case the union was the sample space itself. So these are exhaustive events where E1 union E2 gave you the sample space, and at the same time E1 and E2 were mutually exclusive also. So because of that, just adding E1 and E2 gave you the sample space. I think this gives you a little more idea on what exclusive events and exhaustive events are. Okay, so now another way of writing it, E2. For example, I have E1 is getting an odd number. E2 I wrote it as getting an even number, but I could also write E2 as not even. Whatever is in E1, not even. Do you get it? So that also would not change anything in the answer. It would be exactly the same, because not even means not an odd number. Anything that is not an odd number is an even number. So if you have a set, for example, if you have an event E1, any, or there are too many E's now. If you have a set K and K1, and if you add with that the whatever is not there, that is not K1, if you add with that not K1, you get the sample space itself, because it just means everything. For example, just listen to me carefully. There are 8 students in your class. Okay. No, not for example, there are 8 students in your class. Now if I am saying, okay, this homework is for Niharika, Usmida, Raja and the rest of the students, that just basically means every one of you has to do it, right? So it is just a different way of saying it. Okay, anyway, so that is enough for this video. In the next video, as you see here, we will discuss on how the card deck works.